Hello everyone, this is Nilesh Gule here once again. In the previous session, we talked about the C# functions and arrays. Earlier, we already discussed about the C# types, value types as well as reference types. We already demonstrated the structures and enums in C# and there was one dedicated session for C# classes and objects. Now it's time to take our C# object-oriented programming journey further. So I will get started with the C# OOP programming, a quick review, and there we will introduce one feature of readability, that is region concept. And then today's entire session, we will focus on something called as inheritance and polymorphism. So let me first take you to the Visual Studio and we will create a new project. In fact, I will start with a new blank solution, and in this blank solution, I will give a name, let's say .NET Core OOP demos. Let me once again create the project with exactly same name that we had given earlier, like class objects. And instead of typing the whole code once again, I would prefer to copy and paste whole class and object stuff. So earlier we discussed that class person is a user defined type and it is a reference type. It is having collection of fields and different methods like constructors, destructor, getter setter, facilitators, properties, and even auto-implemented properties. Then we learn the difference of class and object, that we can allocate the object of the class using new person, where P1 is just a reference, and in this case, it is a reference created on the stack. An actual object allocated by the new person will be allocated in the heap. And then we can call its traditional getter setter methods, or better, we go for the smarter alternative, that is nothing but the properties. We also talked about how we can call these facilitator methods for accepting the data from the user and displaying it back. We also demonstrated the parameterized constructor, where while creating the object, we can pass the arguments and actual object will be created on the heap. And then we can call display. And then I have shown one small demo like object initializer, that even though you may not have all possible parameterized constructor, you can use parameterless constructor for creating an object, and at the same time you can initialize the properties. For this purpose, in your properties, you may write the get set part, and especially in this situation, you can also have the init part that we discussed in the structures lecture. Now, let me talk about how we can organize this code better using something called as a regions concept. So C# has got preprocessor directive, hash region, and hash end region, which will help me to divide my code logically into multiple collapsible sections. Like I can create one collapsible section region. Let's say these are my class fields, and I will use end region. Here I can use the Visual Studio feature. Clicking on this, it will be collapsing this particular region. And likewise, I can create additional region, let's say constructor and destructor. Here we have written multiple constructors and one destructor, let's say end region. On the similar line, I can call it as another region. Let's say facilitator methods. This region ends here. We can see our classic traditional getter setters over here. So I call it as a getter and setter methods. And this region ends here. And then we have these properties, which are the smart fields, like region properties. And this is end region. We can have a quick look at this person class is having so many different parts. And if you want to preview any of this region, you can just take a cursor there and it will show you this information. Let me tell you, adding the regions into the code is not affecting any kind of compilation and execution. In fact, compiler treat this hash region statement just like comment. This particular feature is only useful for showing your code or presenting your code in the IDEs like Visual Studio, just to present your code better, just to make your code more readable and hiding some other complexities. Similar way, you can create the regions inside main method. Let's say I have a region where I am testing the setters, getters, and properties. And this was done for the P1 object. In the second P2, we tested the facilitator method. So testing facilitators. And then we can have another testing of parameterized constructor. We can end that region here. And finally, it was a testing of object initializer. That's it. Now this clearly shows what exactly concepts are tried in such a big file. Before I finish this region concept, I want to tell you that you can also have nested region, meaning by you can have one bigger region saying a person class, and it will include the other subregions like fields, constructor, destructor, facilitator, getter, setters, and properties. So you can have another collapsible region called as a class person. Now, this was a quick revision of the person class object, and also we seen a feature how to make our code more presentable inside Visual Studio IDE using region. Let us focus on the main topic of the today's class. And these topics are basically inheritance and polymorphism. So now we will first get started with basic idea what exactly the inheritance is. So let me tell you that inheritance represents either relationship. A simple example is car is a vehicle, or mango is a fruit, or dog is an animal. Now, in this particular case, you understand that your vehicle class is written first with certain properties, with certain fields, with certain methods. And then when you want to write your own car, since we say that car will be having all the properties of the vehicle, you need not to re-implement all those things once again in the car. Rather, you will inherit car from the vehicle, and then all features of the vehicle will be inherited to the car. And then we can only focus on implementing the new features for the car. Here you can take a look at this particular vehicle class. You can consider as like a parent class, and then the car is a child class, where a child is inheriting the characteristics, inheriting the features from the parent. However, in C Sharp, the technical term used for this parent and child are nothing but the base class and derived class, which resembles the terminologies in C++. And I'm sure by the time you also understood what is main purpose of the inheritance. It is one of the most elegant and effective way of reusing already written code. So whenever you want to go for either relationship or kind of relationship, then the inheritance should be considered. Inheritance also allows you the shared behavior, meaning by certain features which are common in two classes with either relationship, you'll find that these features are implemented only in the base class, and then derived class will just reuse those functionality, will just share that behavior. Here we can say that vehicle is general entity and the car is a specialized entity. Let me give you some example first. Let us consider a very basic, very straightforward example. Let's say a person and a student. We will rewrite the person class quickly, and then we will write another class inherited from the person. So let me create a new project. I call this as Inheritance Basics. Inside this, I will write a class person. In this person class, I just want to have some basic members like public, integer, age. And I can have public string name. Good. You can continue to write the further constructors. Let's say I'm writing a parameterless constructor, which is initializing, let's say age is equal to something, and maybe name is equal to empty or nothing. You can also write the parameterized constructor. The parameterized constructor should now take two arguments. One is age, another is name, and inside this we will initialize both of them. Let me make maybe the name as a first argument, age as a second argument, though order doesn't matter. Now this particular person class, I will add one simple method. Let's say public void display person, and inside this I want to display the information about the person, that is name and age. We can quickly do it with the string interpolation, saying that person name is equal to this dot name, and then age equal to this dot age. If you want, you can quickly go back to the main and try creating the object of it. Let's say person p1 is equal to new person. Maybe I'm passing the information over here, and I can simply make a call to the p1 dot display person. Let me test it, making this as startup project, Control F5, and I'm running it. That's wonderful. Now I want to write a class called as a student class, and I understand it very well that student is a person. So every student that I can visualize will definitely have some name and some age. But being a student, it is a specialized entity. It will have something extra as well. What extra student will have? Maybe each student can have some roll number, student can have some marks, he might have some standard division or other information. So how you will implement it? We will write it as class student inherited from the class person, and this inheritance is represented with the syntax colon person. This particular syntax resembles to the inheritance syntax in C++. And inside this, you may go for the additional members that you want for the student. Let's say I want roll number and I might want, let's say, some marks. Again, get a setter. Now, if I want to make a student class constructor, so that constructor should be written in normal way. In this constructor, you can only focus on initializing the data members of student class. What will happen with the person data members? Let me tell you, whenever you will create the object of a student class, internally, it will first execute the constructor of the base class person, and then it will execute the constructor of the student. Let me show you whether it really works. So we can check that by creating the student object. And currently I'm using parameterless constructor only. Now I can say s1.displayPerson. I can use F10 for debugging. And while debugging, let me use F11 to go into the constructor. Here you see that it has gone to the student constructor. But if I press F11 once again, you will see that it will first call the person constructor. It will first initialize the person members name and age to some default values. And then it will continue to initialize the student members in the student constructor. And then you can continue to call the method, the displayPerson method on the student class. We will continue this discussion later. Let me first finish the concept of constructor. What if I want to write the parameterized constructor? Yes, you can write the parameterized constructor, but every time you want to initialize a student, the student initialization cannot be limited to only roll number and marks. You have to consider the other parameters, that is basically name and age. So I will first take name. I will then take age. Then I will take roll number. And then I will continue with the marks. Again, the student constructor should focus on initializing maybe the roll number and marks. But the question is, where we will initialize the name and age? Technically, this should be handled by the person constructor. But at this time, you will realize that when I will try to create the object of the student with parameters constructor, by default, it will always call the parameterless constructor of the base class, person class. Let me show you that as well. So let me create another student s2 is equal to new student, and let me pass some information over here. Let's say I have some student John, maybe the age is 23, maybe roll number is 1, 2, and let's say marks are 87.0. In this particular case, let us check which constructor is getting called. When I press F11, it is going to the parameterized constructor of the student. But again, F11 will show me that by default, it is calling the parameterless constructor of the person. So person is initialized to the default values of name and age. And then the roll number and marks are initialized as per what values I have given. Here you can see that the student initialization is limited to marks and roll number. But name and age, whatever I have given, it is ignored, it is uninitialized. So how I can handle this? Common sense is, in this particular case, this particular constructor must call the base class parameters constructor, which it is not calling by default. And that is the reason I need to call it explicitly. If you recall the concept of the constructor chaining we discussed during the classes, over here also we can use constructor chaining to invoke the constructor of the base class explicitly. And for doing that, we have to use the keyword called the base keyword. And then I can pass the name and I can pass the age. Now let me debug this once again, where you can see that first the student constructor is called, which is in turn calling the base class parameters constructor, which is initializing the name and age correctly. And then the derived class constructor is initializing roll number and marks correctly. And then we have this student object fully initialized as per our requirement. Earlier, the way we had written the display person method, we can continue to write a display student method inside this. So let me write a method public void display student. And again, display student method should primarily focus on displaying the information about the student, like student, and I will mention the roll number is equal to this dot roll, and then marks is equal to this dot marks. Good. We can call this, let's say s2 dot display student. And you should not be surprised, since display student is only displaying the information roll and marks, you will see in output only roll and marks are displayed, but the name of the person, the John, and his age is not displayed. How you can ensure that those things are also displayed? Now there are two ways. What I can do is, from main, I can call the methods of the base class as well. Since this particular method display person is public in the base class and our student class is inherited from the person, all the members of the person are inherited into the student. So this display person method is now also part of this particular student class. And that is the reason I can call this display person method on the student class. So when I run this, you can check the output. Yes, it is displaying this John 23 and also roll number 12 and 87. However, in this particular situation, you need to call these things twice. Can we avoid that? As I said that there are two ways I can do that. Instead of calling this display person method over here, I can call this method inside the display student method of the student class, and I can make a call to the display person in this case. You can run this and this will also produce exactly same output. This is a better way of writing the code. So whenever I'm asking to display the student information, it is displaying the full information about the student, where the basic information is displayed with the display person, and then the specialized information is displayed by the display student. However, you may also call display method directly without using any keyword, because all the members of the base class are inherited in the derived. So you may call it directly. This keyword is optional. Or there is another way, you may use a keyword called as a base over here. As you know that we have used base keyword to represent the base class part. On the similar way, over here, I can use the base keyword to access the base class members explicitly. So if I want to put this thing diagrammatically, how I can see the student and person object working there. Let me try to put a simple diagram. Let us talk about this particular object, student S2. So S2 is a reference type. So S2 is a reference that will be created on the stack. And the actual object, let's assume that it is created in the heap at the location, let's say 1000. I'm drawing more of logical diagram of the student object than the actual memory layout. So this particular student is having something called as a name and age. But have you noted that this name and age is actually the part of the person? So these are basically the person members, which are initialized to values John and age is equal to 23. However, the student also have the additional members that you see roll number. This roll number is initialized to given roll number 12 and marks are initialized to the given marks, let's say 87. So you can see that every student is having all the members of student plus person. This gives you clarity that how inheritance is working. And also you've seen that all the members of the base class are inherited to the derived class. If you want, from the derived class object, you can access the derived class methods as well as you can also access the base class methods. Of course, assuming that its access level or visibility is public. We will talk more about access modifiers. Now, what all different access modifiers available? You can take a look at the access modifiers quickly. So C# allows you these 6 different types of access modifiers for the class members. When I say class members, it could be fields, it could be methods, it could be properties, and so. The first one is private. What is private? The private members are accessible only inside the class. So you can access the private members inside the methods of that class only. They are not accessible to the derived classes. They are not accessible outside the classes. We had already used this private concept. And then there is another one that we used already, and that was nothing but public. The public is accessible inside the class as well as outside the class. And as you are in inheritance, public is also accessible in the derived classes. In fact, the public is accessible anywhere using object name dot. Then there is one specialized field or specialized access modifier that is protected. The protected members are accessible in that class and also accessible in all derived classes. But these protected are not accessible outside the classes. So if you want to have certain members which are visible and accessible only to the current class and all its inherited classes, you should consider them as protected. Apart from that, there is one more access modifier we have, that is internal. The internal, I guess we discussed this earlier. Internal talks about the particular member is accessible in all the classes in the same project, in the same assembly. So the scope over here is an assembly level scope. You can access that particular class member into any other classes by using object name dot member name. And then there are two more specializations. One is protected internal and another one is private protected. The protected internal talks about any member which is declared with this access modifier will be accessible in all the classes in the current assembly due to internal. But it will also be accessible in all the classes outside the assembly which are inherited from that class. It is due to protected. So if you want to understand protected internal, you can see it as the effect of either protected or internal. I repeat once again, due to the internal, it is accessible in all the classes in the current assembly. And due to protected, it is accessible outside the assembly, but in all inherited classes. Well, then what is private protected? The private protected is where the members are accessible in the same class due to the private. Due to the protected, they are accessible in all the derived class in that assembly. But the private protected suggests that it is accessible to all derived classes in that assembly only. You cannot access it into derived classes outside that assembly. This private protected is one of the new access modifier added in the C# language. Well, now that you've seen the basic inheritance concept, you've seen how the constructors are executed. We talked about the method inheritance at the very basic level. Quickly, one theoretical concept I want to bring to your notice, and that is nothing but types of inheritances. The types of inheritance over here, currently the example that I've shown you, where the student is inherited from the person, we have single base class and single derived class. That is basically the single inheritance. Then you can have multi-level inheritance, where I can say that mango is inherited from the fruit and fruit itself is inherited from the food. That is called as a multi-level inheritance, where we have multiple levels of inheritance. Then another example is hierarchical inheritance, where we have one base class and then multiple derived classes. Here you see that cat, dog, or other animal classes are inherited from a single base class animal. And then there is a special case called as a multiple inheritance, where we can have multiple base classes and a single derived class. Here you see that the backend developer can develop the application backend. The front-end developer can develop the application front-end GUI, but a full stack developer should be able to develop the backend as well as front-end. So I want all the properties of the backend developer and front-end developer to be present in the full stack developer. And that is the reason we are doing multiple inheritance. But a very important note over here, like Java, C# also doesn't support multiple class inheritance. Multiple class inheritance, this particular stuff is not supported in C#. Yes, C# can support something called as a multiple interface inheritance, and we will discuss about it in more detail in our interfaces lecture. Now, there is another special type of inheritance people call it called as a hybrid inheritance. And what is hybrid inheritance? It is nothing but any combination of this multi-level, hierarchical, or multiple inheritance. If you are making any mixture of it, then you can call it as a hybrid inheritance. So typically, as you start implementing any project in OOP style and doing inheritances, So you have these different choices that you can go for: single inheritance, multi-level inheritance, hierarchical inheritance, multiple inheritance, and most of the real world project, they will be all combination of it, something called as a hybrid inheritance. Now that we had a little discussion about these basic features, let me take you to bit advanced stuff, where I will take another example and we will discuss something called as a object slicing feature. Let me first show you with this example. Suppose that we have the vehicle class as a base class and car class as a derived class. Now we can always create a vehicle object and referred by the vehicle reference. We can always have the car object created, referred by the car reference. But don't you think that every car is a vehicle? And when you are saying every car is a vehicle, meaning by you are referring to a car object in the perspective of a vehicle. This is very much allowed into our OOP programming languages, and that is can be discussed as a vehicle V, a vehicle reference pointing to the new car object. Here the reference is of base class, but the object is of derived class. In other words, I am looking at the car object from the perspective of the vehicle, where I may not be interested in all the specialized features of the car, but I'm more interested in the features of the vehicle. This particular concept is called as object slicing, because in this particular case, with such a reference, we are only accessing the partial features of the car. We are not referring the advanced features of the car. We are only seeing, we are only referring to those functionalities of car which are inherited from the vehicle class. That is the only reason purposefully I have not shown arrow like this. Purposefully I have shown arrow like this, so that I want to indicate over here the vehicle reference is technically referring to the vehicle part present inside the car object. In fact, in this particular case, as we are saying, a derived class object is referred by the base class reference. It is also called as a upcasting. It is also called as a upcasting. In most common cases, we draw inheritance in the UML diagram like this. So vehicle, we draw upside, and car, we are drawing like this. In this particular case, the car object will be pointed by the vehicle, and that is the reason this is referred as upcasting. And you need not to do anything special over here. This is very well accepted by the compiler. You need to just assign, and compiler will be able to deal with that very well. Let me show you the impact of it. We can check it into this class, and we will also have another example. Let's say I have person P2 is equal to new student. Yes, upcasting is getting done over here. And over here, I have some student, let's say Sachin. The age of the student is, let's say, 21. The roll number of this student is, let's say, 234. And the marks of these students are, let's say, 86.0. Now, with this P2, you can only access the functionalities present inside student but inherited from the person class. So you can check that I can make a call to the display person. I may call the properties name and age property. So display person is possible. name and age access is possible. However, if I try to access the feature, something called as a display student, or if I try to access the properties like marks and roll number, it is not allowed. So trying display student will actually give me error. This is nothing but object slicing concept. Let me talk about this example once again, but with a new project. In new project, I'm creating a console application where we can talk about, let's say, object slicing and maybe virtual. Just to save our little time, I will copy the person class as it is there. And then I want to write a new class called as a player, a sportsman. So every player is a person that can be done by using inheritance relationship. Now inside this, let's say the every player should have some sports associated with him. So public string, let's say sport. Done. Now likewise you can write the constructor, and into the constructor you can give a default sport. Maybe you can keep it empty. By default, the person is doing initialization of the name and age, and the specialized member is initialized into the player constructor. If I want to create the parameterized constructor, the parameterized constructor should take the name, should take the age, and then also should take the additional members. Over here, we can initialize the sport directly, and initialization and name and age will be taken care by the person constructor, and we can call it by using base. So this is just a quick revision of what we discussed earlier. Now, what I want to do is I want to write a method display inside the person. And on the similar line, I want to write another method with purposefully same name display over here. Inside this, I want to display the information about the player. And that player information, I'm displaying the sport extra. So this dot sport. Now, how we can call this? Let me write the person P1 is equal to new player. We already discussed that the derived class object can be referred by the base class pointer. If you want, I can pass certain data members over here. Maybe my data member is, let's say, Messi name. Let's say I'm passing some age, and the sport over here is football. Now, when I call p1.display, exactly which display will be called? Whatever theory we discussed some time back, I was trying to tell you that by default, with a base class reference, I can only call the base class features inherited into the derived class. So you will find that this particular display of base class is actually inherited into the player class. And that is the reason with this particular reference P1, I can only call the base class functionality. Let me show you. Let me make this particular project as a startup project, and I'm pressing F10. F10, F10. And when I say F11, you can see that it is actually calling the person's display. It is not at all calling the player display. And that is the reason my output is limited to the person. Of course, when you create the object of a player, let's say player, maybe P2 is equal to new player. And in this particular case, if I'm passing something like this, And if I'm calling display, now what will happen? 100%, since it is a reference of the derived class, it will call the functionality of the derived class, which you can cross check quickly. Over here, it is calling the derived class functionality and it is displaying that information. But what if I want to also display the base class functionality? I guess you know the answer. You can make a call to the display of the base class. Just keep in mind, if you call the display directly or if you call this dot display, in that particular case, this display will call exactly the same function because the name of the function is exactly same in base class as well as derived class. And this might go in a kind of an infinite recursion that will cause eventually my program to fail with the overflow error. So in this particular case, it is mandatory that I have to call it by using base.display. Now let me try this once again. F10, 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 F10. When I say F11, it is going to the display of the player. And from display of the player, base.display, it will actually refer to the person display. And once person display is over, you can return back to this. You can display the player over here. And that's it. My job is done. Let us stop debugging. Now the question is, what exactly happened? With the base class reference, you can only access the base class functionality. You cannot access the derived class functionality. Is there any way that programmatically I can check whether this particular P1 is pointing to the base class or derived class, and accordingly, can I call the actual derived class features? Answer is yes, that can be done. Let me show you with next example. Let's say P3 is equal to new. It could be a person or it could be a player. For example, you may ask the choice to the end user, and based on the user choice, you can initialize it to the person or player. Now, I want to technically check whether the P3 is pointing to a person object or P3 is pointing to a player object. That kind of check will be done using something called as an is operator. Is operator always returns you the Boolean value indicating this particular P3 is pointing to the object of the given type or its derived type or not. Like, for example, if I'm trying to consider, let's say P3 is player. Take a look at P3 is player. P3 is already pointing to the object of the player class. So if I say P3 is player, it will display as true. However, if it is person, then running this once again, it will just make it false. However, let me check it with the another one. Let's say P3 is person or not. Now, in this particular case, you can see it very well. In this particular case, P3 is pointing to the person object. So P3 is person. Yes, it must return true. Let me run this. And you check that, yes, P3 is person is returning true. But P3 is player returning false. There is one small confusion that people usually have. And let me show you with another example. Let us go for writing person P4 there is equal to new person. And in this particular case, let me check the similar thing once again. P4 is player, P4 is player, and P4 is person. Let's consider that P4 is not pointing to the person, but it is pointing to the player object. Now, in this particular case, I'm very sure that P4 is player. Since it is a player object, 100% you expect this to be true. But what about P4 is a person? Here you will find that P4 is a player. But most commonly, people forget that every player is a person. And that is the reason when I say P4 is person, since it is a player object and every player is a person, this will also return true value. Do you see this? This is one of the important things that you must note. So is operator, what exactly it check for? So it will return true when a reference is pointing to an object of the given class or its derived class. In this particular case, player is derived class of the person, and that is the reason P4 is person returns true. Otherwise return false. Where you can see this example over here. Here you find that P3 is a person. P3 is a person. It is not a player because person is not inherited from the player. Now, where you will use this particular functionality? I will use this particular functionality to actually call the methods of the derived class object. Meaning by, let us take another example. As I have person P5 and based on the user choice, I'm going to initialize this to either new person or I might initialize this to new player. Either this or that, of course, not both of them. Correct? Now, depending on the choice, I want to initialize it and I want to display it. Can it be done? Answer is yes. And for that, what I will do? I will check if P5 is player. If P5 is player, I want to access the functionality of the player. So maybe I want to access the functionality of the player. I will create a pointer P for the P5 and then I can do the actual initialization saying that name is equal to something, age is equal to something, and sport is equal to something. Done. And then we can display that. Please note, in this particular case, player is a derived class pointer, and through that derived class pointer, I am accessing all the functionalities of the derived class. This is absolutely logical and it should work. But this will happen only when P5 is pointing to a player object. If P5 is not pointing to the player object, maybe I want to continue with the features considering it as a normal person. So person P is equal to P5. Of course, there is no casting is required over here because the person reference P5. Then we can initialize P dot name is equal to something, P dot age is equal to something, and P dot display. So here you see that since P5 over here is person, in this particular case, my else block will be executed and only the person information will be displayed. Right? However, if the P5 is pointing to a player object, in this particular case, it will display the whole information about the player. I hope this is clear. In this particular case, to access the player functionality, I have typecasted my person reference back to the player. This particular feature is referred as downcasting. And please note that downcasting is never done automatically. You have to do it programmatically by putting the explicit cast. And this downcasting becomes safe because we had already provided a check. If P5 is of player type, then and only then do this downcasting. Otherwise, do not perform this casting. So this particular cast is guaranteed to work well. If I had not done this check earlier, in that particular case, runtime casting of this may be successful or may be failed. If P5 is pointing to the person, in that particular case, typecasting it to the player directly will raise invalid cast exception. So if you want to do the casting, it is always a great idea that you can do this particular casting by using specifically is operator first and then perform the downcasting. Well, this can be done by one more method. The another method of doing this could be using as operator. So what is as operator? Let's say I can use P5 as player, and that I can assign it to, let's say, player P6. What this as operator does, as operator do two things simultaneously. First, it will provide the runtime check whether P5 is pointing to object of the class player or its derived class. And if runtime check is positive, then it will do the actual casting, means downcasting in this particular case. In case the check is failed, it will not do the downcasting at all, and P6 will be null in that case. So if you at all want to call the player functionality over here, you can have a check that if P6 is not equal to null, then and only then you can access the player functionality. Let's say you may call, let's say, P6 dot display again. I'll just put one message, let's say player found or something like that, and you run it. Let us cross check. In this particular case, currently person reference pointing to the person object. In that particular case, this P6 will be null and this player found will not be displayed. Correct? However, if I use person P5 is equal to player, in that particular case, yes, player found, and I can call the display method of the player by downcasting. I guess this gave you idea regarding how the inheritance is working and how we can perform the checks at runtime, how we can call the methods of the derived class as well. There is another small concept related to this object slicing stuff. If you go to the method of the player class, you will actually see one warning because we had written a method in the derived class with exactly same signature as of base class method. So I see one warning over there saying that player.display hides inherited member person.display. What exactly it means? If you have the player reference, then through this player reference, you can only call the method of the player class. Now, though the base class method is inherited, still you cannot call that particular method of the base class over here. In other words, the person class display is hidden or shadowed due to the display method of this particular player class. Well, so what should be done? To be frank, you cannot do anything with this. However, you can document this. You can tell that whether you are doing this intentionally or you are doing this accidentally. If you are doing it intentionally, you should be using a new keyword over here. This new keyword is telling the compiler and maybe your teammates that this display method is a new method in the player class and it has nothing to do with the display method of the person class. So that everyone, compiler, yourself and your teammates, they are clear that this particular method is implemented as a new method which will be called on the derived class reference, and it is purposefully hiding the base class method. Well, but what if you do not want to do this? If you do not want to do this, maybe you want to tell the people that display is the enhancement or the modified behavior of the same base class method. How do you inform this to your team? How do you inform this to the compiler? Now, this can be done very well by using something called as a virtual functions. What I can do is I'll comment this for now and I will rewrite this with, let's say, display method over here. I want to make it virtual. And now the same method, I want to write it enhanced version. I want to write it into the derived class. And I want to tell it to the compiler that this is not the new method. This method is an enhancement, is a modification of my base class method. And that is done by using override keyword. Override simply means that this particular method of the derived class is overriding the behavior provided by the base class. And programmer should do that overriding when base class method signature or base class method implementation is not suitable for your requirement. And you want a modified behavior in the derived class. Now, this is really a special case. With this special case, with base class pointer, you can access the derived class methods as well. Let me show you the demo of this. I'll prefer to write another main so that there is no more confusion into this. And I will create the similar object once again. Take a look at this. Now over here, I have, let's say, person pointer. And this person pointer or reference is pointing to the player object. I'm still calling the same display method. This will automatically call the display of the player class instead of sticking to the person class. Let me run this and show you. Do you see that the player class display is called? You can debug this. And now you can check when I say F11, it will take me to the display method of the player. Since we are calling the base class display explicitly, it is calling the person display and then it is printing the player's port as well. And you see this output. So there are two ways when you are redefining the method in the derived class. One way is either you want to write entirely new method which is hiding the definition of the base class, and this method has nothing to do with corresponding base class method. Or the second implementation where the base class method is declared as virtual and then the derived class want to implement that particular method once again. This re-implemented method is providing you the modified behavior, enhanced capability in the derived class. And if you are doing such kind of method overriding, then the base class reference can be used to access the derived class methods. This particular feature of redefining method in the derived class is called as method overriding. And in that particular case, take a look at this. Depending on the type of the object, actual method will be called. Means if my object is of person type, then you will see that exactly same call will now call the person method. And if person P is pointing to the player, then exactly same call is calling the player method. So here the method is always called depending on the type of the object, not depending on the type of the reference. This is also known as something called as runtime polymorphism. Here display method is having two different implementation. Polymorphism word has got a literal meaning, poly and morphism. Poly means many, morphism is taking forms. So here you see that display method is taking two different forms. So one is in base class, another is in derived class. And then we are calling the appropriate method, or you can say that CLR is calling the appropriate method depending on the type of the object. This particular feature is referred as runtime polymorphism. Of course, there is another concept called as a compile time polymorphism. What is compile time polymorphism? The compile time polymorphism is related to the concept where in a same class you are writing multiple methods with the same name but different arguments. So when in one class you have the multiple methods with the same name but different arguments, then your C# compiler will decide which method to be called depending on the arguments passed. If the person class object is created like this, it will call my parameterized constructor. But if the person class object is created like this without any argument, in that particular case, the parameterless constructor is called. Here, compiler decides which version, which form of that particular method is to be called. And that is referred as compile time polymorphism. This particular feature of writing multiple methods in the same class with the different signatures is called as a method overloading. And in this particular case, since it is a constructor method, you can also call it as a constructor overloading. In this particular demo, we had idea about the region preprocessor directive. We talked about inheritance. We discussed the access modifiers. We talked about the different types of inheritances. We learned the core concept of inheritance, constructor chaining, how the methods are inherited. We also discussed about object slicing. We talked about upcasting, downcasting, and apart from that, we also seen some new things like the method hiding concept. We talked about the method overriding concept. We talked about polymorphism, compile time polymorphism, that is method overloading, and runtime polymorphism, that is method overriding. This is just part 1 of inheritance. In the next session, we will talk about inheritance and polymorphism to the next level, where we will take some big example and we will also explore the further inheritance concepts like abstract classes, sealed classes, abstract methods, and so on. See you there. Bye-bye.